All right, welcome to class. We want to discuss the case 3 or part 3 of current electricity. In this case, we are having a question here. We are told that a radio is operated by 8 cells, each of EMF 2.0 volt, connected in series. If 2 of the cells are wrongly connected, the net EMF of the radio is. Now, what do we do here? Let's profile solution to this in series. So what do I know to do here? We know that if you do this one, all of this one becomes 8 times 2. That will give me 16. That is what we have for this. Then we are now told that if 2 of the cells are wrongly connected, first off, the first case is this one. If 2 of the cells are wrongly connected, that means that this will no longer be 8 anymore. That becomes 8 minus 2. So 8 minus 2 here, these 2, we are going to remove that. So if they are wrongly connected, if 2 are wrongly connected, what do we do? That becomes 8 minus 2. So this will give us 6. Remember that it's still in series. So that means that from here, I can now multiply 6 times 2. That will give me 12 here. So I have the total to be this and this one. So to make it 1, to get the value to be 1, what do I know to do here? What do I know to do here to get the value to be 1? I will simply say that from this place, I can now have this to become the total. That becomes 16 minus 12 here. What do I have? I have 8 volts. So this is what we are here given as our variable. This is it. Next number 2 here. We are told that a cell supplies the current of this first. The current has been given. That's the first current. Let's put it as first current has been given to be 0.8. Second current there. Second current has been given to be 0.4 ampere. Then they said it went through this first ohms. Remember that your SI unit for resistor or resistance is ohms. Then next ohms and next resistance is 5 ohms. So they now say respectively, calculate the internal resistance of the cell. So what we want to do now, I want to calculate the internal resistance, which is small r. That's what we want to calculate. So how do I do this one? We say recall that I will give us E over this plus this. This is what we have here. Now, observe that from here, we can make E some of the formula. Why? Because we have currents. We have this one. We are looking for this. So if you make case 3, please. If you make, let me put it here as case 3. So if you make E some of the formula, we are going to have that electromotive force becomes I into bracket I plus this from here, please. From here, making E some of the formula. The reason is because E is not given. So let's work with the first one. So we have current. We have the first one. Look at this now. This first one will go with this first one. The second one go with this second one. Please don't forget. So let's deal with that. So the first one here is 0.8 into bracket. I have that as 2 plus R. Remember? So this is my E here. This is for the first one. We'll call this one equation 1. Next up, come to this same formula. The second one now, go back to this place. Second one now, my current is 0.4. Second one, this is the second current, which is this one, is 0.4. I have 0.4 into bracket. Resistor there is 5. So I have 5 plus R here as my equation 2. So what do we do here now? We are going to now comparing both equations. So it means that remember that I said this E electromotive force is equal to this. Why is equal to this? That means that I can take this one and put it here to be equal to this. So I will write this one first, write the up one first, 0.8 into brackets 2 plus R here is equal to this one, 0.4 into bracket 5 plus R. What do I know? Look at this. If we say X is 4 here and another X is 2X here. Since we say this X is equal to this, and this same x, which is what is here, is equal to this. So I can say compare. I can, since we say x is this one, I can remove this one and put here because we say x is this one. This same x is equal to this one. I can also remove this x now and put 4 here. It's the same thing. Anywhere you want to put it is the same thing. So from this point now, you are taking the first one over the next value there. So what do I have here is that I'm going to open my bracket. If I do that, opening my bracket, I will have that 0.8 times 2. This will give me 1.6 plus. Will give us this. So this one, 0.4 times 5. I'm having 2 plus 0.4 R. This is what I'm having here. So collect like terms. So I have that this and this comes together. That means 0.8 R minus 0.4 R. That will give us 2 minus 1.6 here. From this point, what do I know here from this point? I have that if we do this one, we are having 0.4 R. Then that will give us, subtract that one, 2 minus 1.6. I'm having here as 0. This. So divide this to this, divide this to this, so that this take care of this. R becomes 1 ohms. So this is how this is done. Please kindly do yourself a favor. Tell if you are in 100 level, if you are writing Post UTME, if you are planning to write this forthcoming GC, WAEC and NECO, please do well to help yourself. Share this massively. Tell this to your friends and loved ones, your community, your school, your church. Tell them about this. We solve past questions here. So we are dealing with current electricity. Please do well to follow, share, and like. So here is my number 3 question here. Now we have a battery of EMF to be this, and then we have an internal resistance to be this. So we are told that the internal resistance question, this is connected in series. So what do we do? Because it's connected in series now, it means that my R1 is given to be 1.5 ohms and my R2 is given to be 4.0 ohms. So because this is so, recall that from our formula, I will give us E over R plus this. So remember that this one is 1. So because it's connected in series, meaning that we can add them because it's connected in series. So remember what we say for series here. We said that for series resistance, okay, for series, let me put it here. For series, it means that R will give us R1 plus R2. So this will give us 1.5 plus 4.0. This will give us 5.5 ohms. This is what I'm having. So I'll put it here. I'll say my current here becomes, what is my electromotive force, which is 12.0 all over. What is my R now? This becomes 5.5 plus, remember, my small r is 0.5 here. So if you do the math, I'm having that 12.0 here. This will give us 6. So if you divide this, I'm having here to be 2 ampere. Now, the question is that we should find voltage. So we say recall that V becomes IR here. So I already know my current now to be 2 times, what is my R from the beginning? My R from the beginning is 5.5, sorry. Look at it, 5.5 here. This one, 5.5. So if you do the math, I'm having 11 volts. So this is how you calculate number 3. Very simple. Please do well to tell this page or this channel to your loved ones. This is where we solve past questions for forthcoming GCE, for WAEC, for NECO, for Post UTME, and 100-level student. This is where we do the calculation. I promise you will be so good at calculating current electricity because these questions are so simple. So this is how all of these are done. So let's quickly run over dealing with question number 4. Question number 4 here. So now let's check number 4 question. We are told that the terminal voltage of a battery is this. So now observe that if your potential difference is appearing twice, look at this, 1, 2, and your current is appearing twice, it means that you can do it like this. So V1 will give you, the first V1 there is 0.4 volts. Next up, I have my first current, which is 2 points this. Next up, what do I know now? I have my V2 as my 2.0 volts, and I have my I2, that's my second current, to be what there? To be 3.0 here. So 3.0 ampere. So this is what I know. So I want to calculate internal resistance, small r. We don't know of this. So what do we do going further? What do we do here going further? Now, because this variable is 2, this is 2 and this is 2, it means that you can solve them individually. So that's the first thing you do. So solving this individually, for the first one here, since we know this one, we know this one, we can calculate. Remember they say we should calculate small r. And the only place we can see our small r in this place is this formula. Look at this, where we say E becomes this plus this. Don't forget that, please. So I have this one. We are going to repeat this one twice. Please note this, note this. Let me make E solve the formula. Why? Because we are not giving electromotive force here. So first, I will say my E becomes I into bracket this plus this. So everything here is for the first one. First one. That is everything here. So now, watch this. Okay, no, in this case, this formula cannot work in this case. This formula cannot work because I'm not giving resistance, but this can work where we have this minus IR. This can work. Yes, this can work here. Now, what do we know here? Please watch me, watch me. I can make E some of the formula because I'm not giving E here. So I can say E becomes, put this one here, take it back. That becomes, take this one here. That becomes minus IR minus V. This one going over. So from here, we are not giving electromotive force, but we know that we want to find small r, and we have this. So this is 1, 1. We are doing as 1, 1. So what is my first current here now? My first current is 2.0 small r, because we're looking for small r. What is my first V1 here? Is 0.4. I'll take this as my equation 1. Yes. Next up, I will still use the same formula now and repeat the same thing. So we'll say electromotive force, therefore, becomes, the first one is minus IR, then minus V2. So let's do this one here. So here becomes minus, what is my I2 here now? Is 0 point this one, minus what is my V2 here now? Is 0 point this one. So I have this. So we are going to now compare. By comparing both equations, we know that we are told that this first E is equal to this one. I just told you that if you have this is equal to 4 and this to become 2x here, since this x is still what is here, that means that this x can be equal to 4. So I can take this, because they say x is this one and x is this one. These are the same as, I can take this one, that this same x is equal to this. I can take it and put it here, equals to this. Or I can take this 4 and put it there, because we say this same x is equal to 4 here. I can put it here. So that is the same thing we are doing here now. So we said all of this one is equal to this one. So I'll pick the first question here, which is minus 2.0 R, then minus 0.4 here, will give us equals to the next thing here, minus 3.0 R here. Then minus 2.0, minus 2.0. So no need to put your vote, please. So what do we know to do now? I can say 2, collect like terms, please. This comes over, become plus. And then minus 2.0 here will give us 0.4. If you do this math, we are having R. This will give us 1 R or 1. So this will give us just 2 ohms as our variable. This is how this is solved. I'm telling you, this is the best channel to introduce to your friends, your church, your colleagues, your people around, your community, the mocks. Tell them about this channel. Here we solve JAMB and past question and other available things. If you are doing Post UTME, you are in 100 level, you want to write this forthcoming GC, your WAEC forthcoming, this is the best channel to be. Please share this, tell people about it. See you as we solve more questions. All right. Number 5 and 6 in current electricity is here. I bet you are going to be extremely good at solving current electricity. No matter how the question is, no matter what you are writing, Post UTME, WAEC, GCE, forthcoming WAEC and GCE, please, JAMB. This is the channel to be. Tell this to everybody around. Share this, like this, repost it. Tell people about this channel. So what do we do in number 5? We are told, we want to solve number 5 solution here. We are told in this case that a cell whose internal resistance is this. So this is number 5 solution. Number 5. So internal resistance is given as this over this. This one. It says delivers a current of this. A current of 4 ampere. So they say, what is the external resistor? Sorry, the lost voltage of the cell is, we can solve it in 2 ways, but in order not to waste our time, we can use this. So we say our lost voltage is given as IR. Simple. So, which V becomes, what is my I here? Is 4 times 0.5. Obviously, this will give us 2 volts. This is how this is solved here. This is a very simple question using the formula. Very much simple and correct. So lost volt is given as this in this question. Number 6 here, we are told that the resistance R is connected across the terminal of an electric cell of internal resistance. So R is always anything inside, as mentioned, the internal resistance as this. So we have this. They said, and the voltage was reduced to this. So V, the moment you hear this word reduce, look at this, reduce. It means that the electromotive force has been reduced. That means the current has been reduced. So they said, and the voltage was reduced to 3/5. So meaning that since I'm putting V here, it's 3/5 E. Yeah, that is the efficiency of, that is the electromagnetic force of this cell. So the moment this one is reduced, that means you are reducing the value of the electromotive force. So you must add E to it. That's what we are saying. You must add E to it. So if it is reduced or it is increased, you must add whatever is increased there, E to that thing. So this is what we have. Now we are asked to find the value of big R. So we don't know big R. So since we are given this here, I can simply say that I is equals to, because the only place we have this small r is in this case. This is it. This is where we have it. Now, from here, what do we know to do? We know that if you look at this question critically, we don't have V here, but we only have this one. So I can say this value will give us what? E all over R plus 2. Remember, this one has been given here. So since I have this, I can call this my equation 1. Now, what's the next thing I would do there? I can say recall that V becomes IR. Remember, we are looking for this big R here, and we already have I. This is my I. So, and we already have V. This is my V. Anyway, you see V now, remove it and put this one. So I'll put 3 over 5 E here, then equals to, all of this one now is this one. So I will remove only this I and put this one here, which is E all over R plus 2. Then times this R. Remember, I did not touch this R. This is what we are looking for. So from this point now, what can we notice? We notice that this will give us 5, and then this one, E R here, all over R plus 2. But observe that in mathematics, if I have 2x equals to 4, I can divide like this. X here will be 2. It's also the same thing as when you divide both sides by 2. It's the same thing. That will give you 2. So this is exactly what we are doing here. From here, this can take care of this because we don't need anything electromotive force. We are not giving electromotive force here. So in order for us not to waste our time, eliminate it out. So since we have eliminated it, we now have that 3 over 5 will give us R, this R over this R plus 2. So here now we'll cross multiply here. 5R is what I'm having first, then equals to 3 into bracket R plus 2. So 5R here will give us 3R plus 6. Collect like tenths. I have 5R minus 3R to give me this. Do the math here. I'm having this value to give me this. Do the math. I'm dividing here by 2. This take care of this. This take care of this. So R becomes 3 ohms. So this is how this is done. See you in the next class. Bye-bye.